Hi, this is Miss Gonzalez. Today we're going to have an intro lesson into logarithmic functions. So this is going to be probably a little bit longer of a video, so please feel free to go back and look at the video as many times as you need. The following slides in the Nearpod lesson will be extra notes to give you time to write it down. So you can either write it down with the video or you can write it down afterwards. So first, what I want you to do is take a look at the graph over here. So the blue is your exponential function, and the red is your logarithmic function. Okay, so the logarithmic function is considered an inverse of the exponential function. That's why they're showing you the y equals x line, because remember, all inverses reflect over that line. So all logarithmic functions are going to look like this red curve here. Okay, they follow the equation y equals log. Here is your base is little instead of being big. And so this is log base b of x gives you an answer. In terms of the inverse, how you would look at this is b to the y power is going to give you x. And that's what you kind of want to think about. So b to what gives you this as an answer is how we evaluate it. Otherwise, you're going to be using your calculator. What I want you to realize anytime you're using your calculator is log is always to base 10 on your calculator. So as we go through these units, we'll talk about a thing called change of base that allows us to use the calculator. Because unless the base is 10, you cannot use that calculator. You also have the ln button. ln is log base e. So basically, you're talking around the 2.71, etc. Number for being the base. So your calculator either is in this form or in this form. It cannot do your simple one. So if you're asked to evaluate a more simple log, we're asking you to use your number sense, or we're going to ask you to use the change of base formula, which will come later on through this unit. Okay, so more examples down here. This is just showing you basically exactly what I wrote up here. If you want to copy that down, that's in the formula part. So here, this is asking to what power would give you 1/4? Well, if you remember from the other unit, we were talking about that negative. When we were writing equations, the negative power moves it to the denominator. So 2 to the negative 2 would give you 1/4. Here, what would give you 1/2? Well, 2 to the negative 1 would give me 1/2. So this is of the equation log base 2. That's why everything is to the 2 power of x. So you're asking yourself, 2 to what gives me x? So if this is the x, 2 to what gives me this? 2 to the what power would give me this? 2 to the what power would give me 1? Well, the only thing that could give me that is 0. 2 to the what would give me 2? Well, that would be 1. 2 to the third is not something I would ask. 2 to what gives you 3? You could tell it's a decimal. That's not something I'd ask you to evaluate unless we were using the change of base. 2 to the what gives me 4, and that would be square. So we're going to look a little bit more of these examples on the following pages, and then your classwork after you've gone through all the notes in the lesson is going to be in your Pearson book. Okay, so first, before we go over all the properties, I want to look at this. So what I want you to do is try all of these. Remember, I'll do the first one for you. Pause the video and try the rest. So 5 to the what is going to give me 25. 5 to the what? 2. So the y in this case would be 2. Pause the video, try the rest, and then play the video and see if you got it correct. So this one would be 3 to the what is going to give you 1. The only thing that gives you 1 is 0. So in this case, it would be 0. 16 to the what is going to give you 4. Well, hopefully you're realizing it's the square root. So remember, the square root is a fraction exponent. So in this case, it would be 1/2. Okay. Here, you're asking 2 to the what gives you 1/8. Help yourself with that. 1 to the what would give you 8. Well, that's going to be the third power. In order for it to be in the denominator, it would have to be negative. Hopefully you got those. If not, write down what you didn't get about that in your notes to help you understand the difference between that. Notice if the numbers are going smaller, my exponent's going to be 1/2. If the answer turns into a fraction, my answer is going to be negative. Otherwise, those are some common examples. Write those down. Now let's look at some of the properties. All of this property, this exact page is in the Nearpod slides. I just wanted to make sure in part of the video I talked to you about what this is saying. So this is the same as your law of exponents. It just looks a little different. So when we use the law of exponents, again, it's going to be to simplify or expand. And I will show you examples of that in the later slides. But that is what we are going to do. So sometimes you'll be given the simplified side and you'll ask for the expanded side, or I'm going to give you the expanded side and ask for the simplified side. But you're using the same properties. So what I want you to remember, when we had x squared times x to the third, what did you do with your exponents? You added. Perfect. So this would be x to the fifth. So the same thing is going to happen with the logs. When you have multiplication, you're going to have addition. Okay. When you have division, you're going to have subtraction. These go hand in hand. Same as the law of exponents. The power rule, what did you do with it? It was just like the distributive property. So what we could show is I want you just to see this power that normally would be here. We bring it out into the front so I can now multiply. Okay. Write those down if you need to pause the video. Otherwise, it's on the next couple of slides. You're going to want those examples. Here are the examples done out. So if I wanted to, this whole page would be expanding. In the Nearpod slides, you can try to combine and see how good you are at that. So expanding here, first I want you to realize it's multiplication. So multiplication and what go together? Addition. So for number 1, you would start with log x to the second, and we're going to do plus log y. So that would be the first step. Now you also hopefully are realizing, well, we said we shouldn't have squared. What happened to the power? It moved out front. So the final answer would be 2 log x plus log y. Okay. Now let's look at number 2. Number 2 is going to be the same thing, separated first. So log x to the third plus log y to the second. And now minus, because it's division, log z. Okay? So now I can go through for my next step and move the powers out front. So 3 log x plus 2 log y minus log z. And that would be number 2. All right, I'm going to skip down to, for sake of moving around, I am going to do 6, and then hopefully we can fit 10 because 10 looks really complicated. All right, so for 6, notice the power is kind of on everything. So the difference here is I'm going to start with that power, and I'm going to move it out in front, and I'm just going to use parentheses. So now that would be log x. Division is subtraction. So that would be log y. And I would just leave parentheses, just like parentheses are here. I'm going to keep my parentheses here. That way we're keeping it basically together. 10 is going to be done exactly the same. Okay. So for number 10, what you might want to first realize is what is the fourth root? So here you need to remember that fourth roots are also fraction exponents. So back when we had the square root on the other page, it was 1/2. Here it would be 1/4. So for 10, I'm going to write 1/4 out in front. I'm going to put the parentheses and now do the rest. So this would be log x to the third plus log y to the second minus log z to the fourth. And if you are more comfortable with, sorry, trying to make that smaller. If you are more comfortable skipping some of these steps, that is okay. Otherwise, sometimes we need to show our work to be able to be accurate. So now I'm going to go ahead and deal with those powers that I haven't dealt with. So I did the first power because it was on everything. And now I could go back and do the rest of the powers. So the 3 would have to go out in front, plus 2 needs to go out in front of that one, and then minus the 4 goes out in front of the last one. And then that would be your final answer. The Nearpod slides have a lot of extra examples. Try them out. I will again add a Flipgrid video opportunity to the end of the Nearpod in case you still have any questions. Some of you guys have been sending the questions through Google Classroom. I also set up the Remind, many different platforms for you guys to ask any questions. If you guys are getting stuck, please ask. Thank you.